Hello everyone. In this video we are going to solve Day of the Programmer problem statement on HackerRank. So here is the problem statement. Mary has invented a time machine and she wants to test it by time traveling to Russia on the Day of the Programmer, which is the 256th day of the year in the year ranging from 1700 to 2700. Let's understand the entire problem statement in a tabular format. So in the year ranging from 1700 to 1917, the Russians' official calendar, which was Julian's calendar system, was followed, and from the year 1919, Gregorian calendar system was followed. So the transition happened in the year 1918, in which the next day after 31st January was February 14, which was the 32nd day of the year. Now to find the 256th day of the year, we will have to consider this February month, which is with the variable number of days in every year. Also, because of this 32nd day being 14th February, we are left with 13 days in this year 1918. So for calculating the 256th day of the year for the year 1918, we will be keeping an account of those 13 days which were not considered because of this transition. Also, the conditions for leap year were different in these year range. From the year 1700 to 1917, leap years were divisible by 4 only. But from the year 1919, leap years must follow two conditions. The first one is that they must be divisible by 400, which we will be considering for a century leap year. And the next one is, if the year is divisible by 4, then it must also pass the condition that it should not be divisible by 100. So these two conditions must be satisfied in order to make any year leap year from the year 1919. Let's look at the sample input and output and the different requirements for the problem statement. So the input is any year, which is Y, and we have to find the 256th day of the year. The output format is dd.mm.yyyy. So if there is any year after 1918, then for a leap year, the day will be 12th of September. That means if we look at this year 1984, then the 256th day of the year will be 12th of September because 1984 is a leap year. We have to complete the definition of the day of the programmer function, which accepts only one parameter, which is an integer value, year, and the output format is, as already explained, will be in this format. The constraints for this problem is whatever year value we enter must be greater than equal to 1700 and less than equal to 2700. If you look at the sample input given here, 2017, now 2017 is not a leap year. So for this, the 256th day of the year will be 13th of September. For 2017, you can see the explanation here, which calculates by adding the days of all the months. The next example accepts 2016 as the year, and because 2016 is a leap year, so 256th day will fall on 12th of September. The explanation for 2016 is also given. We have another example here, 1800. Now this is a century leap year, and for this again the day is 12th of September. Let's write the code for this problem statement. Now first I'll be writing the condition for 1918 because 1918 does not fall under the requirement for the leap year and non-leap year. As I've already explained that 13 days were less in 1918. Now 1918 is not a leap year. For all the non-leap years, the 256th day will be 13th of September. Now, missing those 13 days of the year 1918, we will be adding in 13th of September and we will get 26th of September 1918 as 256th day. So here I am going to return 26th of September 1918. Now let's write the conditions for leap years. For all the leap years which are less than equal to 1917, they must be divisible by 4. So this condition is for those years. Now I'm going to write the conditions for the leap years which were after 1918. So for 1918, you can see I've already returned the value 26th of September. So after 1918, the year must be divisible by 4, and also it should not be divisible by 100. This condition will go for all the non-century leap years, and if there is a century leap year, then it must be divisible by 400. So for this, we are going to return 12th of September, which will be 256th day of the year. Now whatever value of the year is entered, I am going to change it to str, that means string type value. Whatever value goes from here will be concatenated with 12.09 dot, and then the year will follow. So there is no need to write any condition for 13th of September because this will be valid for all the non-leap years. Let's run the code. So these sample test cases have passed. Let's submit the code. So now all these test cases for the problem statement are successful. Thank you so much for watching this video. Keep working with smile.